Hi everyone, I am Prasad. Welcome to Professor Spark channel. This is 13th class for Electrostatic chapter. Let's go to solve some of the problems based on uniform electric field and non-uniform electric field. A charge Q has a mass m is entered horizontally into the vertical upward uniform electric field E. Take horizontal direction as x-axis and vertical direction as y-axis. What is the shape of the path of charge? See, electric field is in upward direction. So, bottom has positive plate and upper plate has negative charge. So, Q is entered into uniform electric field horizontally. Okay. Whenever it comes to into the uniform electric field, two forces has acting on the body. So one is EQ, that is in upward direction because it has positive charge, and gravity force is downward direction. So net force, suppose here we take EQ is greater than mg, then UQ minus mg. F is equal to what? Ma. So MA is in upward direction. So acceleration is EQ minus mg by m. Anyhow, acceleration is in upward direction. So A is equal to, suppose this quantity I take as K. A is equal to Kj. So acceleration has only along the y-axis. So along the x-axis, acceleration is 0. So body is moving with uniform velocity. So we have only formula: displacement is equal to velocity into time. Suppose at this the point, its initial velocity is u. So this is u, time is t, and displacement along the x-axis, suppose it is x. Now along the y-axis, ay is equal to kj. So here velocity is along horizontal mean, vertically it is 0. So uy becomes 0. I want to displacement. So use this kinematic equation here. S is equal to ut plus half at square. So u is along the y-axis 0. So this term becomes 0. A mean k. So S mean here y. So y is equal to kt square. So what is the shape of path? Shape of path means I want to relate between x and y. See here t is the mediator between these two. So I take here t as a common, that is x by u, and substitute in this equation. Then we get 1 by 2 k into, instead of t I write here x by u whole square. So y is equal to 1 by 2 k x square by u square. See these all terms is constant. Say that is a. So y is equal to ax square. So this is parabola equation. So path is parabola. A charge Q has a mass m is dropped freely in uniform electric field E, which is perpendicular to the gravity field. Suppose I take the body is here. So its mass is m and charge is q. So gravitation field is along this direction, that is downward direction. So electrostatic force is perpendicular to the gravity field. So this is electrostatic force EQ. Initially it is dropped, mean its velocity is 0. Initial velocity is 0. See here along the x-axis only one force is acting, that is EQ. So along the x-axis, its acceleration is F is equal to what? ma eq. So a is equal to what? eq by m. So this is along the x-axis. So body is moving with uniform acceleration. So when it is moving uniform acceleration, to find the calculated displacement, use this kinematic equation. S is equal to ut plus half at square. Initially it is 0, so ux is 0, so this term is 0. Half a mean eq by m into t square. So this is equation 1. Along y-axis, see here, initially the body is in rest position, so here uy is 0, and force along the vertical direction, that is mg. So F is equal to mg, F is equal to what? ma. So mm cancel, a is equal to here g. So body is moving here, uniform acceleration. So use this formula, S is equal to ut plus half at square. So u is 0, so this becomes 0. A is here g, sc here y. So y is equal to half gt square. So this is equation 2. See here, S mean here along the x-axis, so that is x. Okay, I want a relation between x and y. So here t is mediator. Okay, suppose we divided 1 by 2, then t is eliminated. So I take here equation 1 by 2, then x by y, that is equal to half eq by m into t square by, so y is half gt square. Okay, so t square cancel, half cancel, so g is g by 1, so that is 1 by z. So this is okay, eq by mg. So these are all constant terms. So this is constant, say c. So x by y is equal to c, that means x is equal to cy. So this is straight line. So body is moving in a straight line. So what is the acceleration? So this is suppose resultant vector between these two vectors. So force is resultant of this one. So acceleration is along this direction. So body is moving along this line. A particle of a mass m and charge q is thrown at a speed u against uniform electric field E. The distance traveled by it before coming to rest. Suppose electric field is along this direction and charge is moving along this direction. So going on, its velocity is decreasing. Initial velocity is u. So what is the acceleration of this charge? Electrostatic force, F is equal to eq. F is equal to ma, a is equal to eq by m. Now its acceleration is eq by m. Here initial velocity, that is given u. As going on, its velocity decreasing, finally it become rest. So what is the question? What is the distance? So S is question mark. So here a is known, initial velocity known, v is 0. What is the displacement? So what is the suitable kinematic equation for this? V square minus u square is equal to 2as. So v square, that is 0 square, u is u square, 2 a is eq by m. So S is question mark. So acceleration is negative because its going velocity is decreasing. So this is minus and minus. 0 square means 0. So here minus cancel. So S is equal to U square into M by 2 into E cube. So this is distance traveled by a charge in electric field. Electric charge 5 coulombs and mass 0.1 kg is moving from rest in electric field is given by equation E is equal to 5 minus 60, where t is the time. What is velocity after 2 seconds? So electric field is given, that is equal to 5 minus 60. Now the question is, what is velocity after 2 seconds? So time is given, that is equal to 2 seconds. Charge and mass are given. So whenever the charge in the electric field, electrostatic force is acting on that one. So F is equal to E cube. F is equal to MA. Q is given, that is 5 coulombs. M is given, that is 0.1. Bring 0.1 towards this side. It becomes to the denominator. 0.1 means 1 by 10. So 10 is denominator of denominator. So it is numerator. So 5 into 10, that is 50. A is equal to 50E. So what is the E given? That is 5 minus 60. So E is given 5 minus 60. Here electric field is not uniform, so this is variable with the time. A dV by dt, that is equal to 50 into 5 minus 60. So here dV is equal to 50 into 5 minus 60 into dt. Initial velocity is 0, at the time is equal to 0. So final velocity is V after 2 seconds. See here, limits for velocity is 0 to V. So this is 0 to V and time is from 0 to 2. So integration dV, we know that is V. The lower limit is 0, final limit is V. 50 integration of 0 to 2, 5 minus 60 into dt. So this is 50, 0 to 2, 5 dt and minus 60 dt. So this is integration from 0 to 2. So this is V minus 0. So that is V 50 into integration 5 dt from 0 to 2. So 5 is constant, so bring it before the integration. Integration dt is t. So this is lower limit is to 0, upper limit is 2. T is changed from 2 to 0. So final is 2, initial is 0. So 5 into 2, 10. So integration 5 dt, that is 10. Integration 60 dt. Time is variable from 0 to 2. 6 is the constant, so bring 6 before the integration. Integration t, that is t square by 2. Time is variable from 0 to 2. Final time is 2. Initial time is 0. So what is the change? Final minus initial. So first you substitute final value in t, that is 2 square by 2, change mean minus initial, so that is 0. Substitute in t, that is 0, 0 square by 2, 0 square by 2, 0, 2 square by 2, that is 2, 6 into 2, that is 12. So this is minus 12. So 10 minus 12, that is minus 2. Minus 2 into 50, that is minus 100 meter per second. Now the question is, suppose electric charge 5 coulombs and charge 0.1 kg is moving from rest in electric field is given by equation E is equal to 5 minus 60. At what time the charge will become returned back? So electric field is given, that is 5 minus 60. So initially electric field is positive because initially mean time is equal to 0, substitute time is equal to 0, then we get here E is equal to 5. So electric field is positive. So electrostatic force is also positive. Suppose this is electric field is direction. Now charge is here. So force is also along this direction. So due to that, going on, velocity is increasing. But as time is increasing, electric field is going on decreasing. At the certain stage, electric field become 0 and it become negative. So when the electric field is negative, mean electric field direction become changed. So due to that, going on, velocity decreasing, finally somewhere it is stopped. It returns back because electric field force is along this direction. So at this the point where the velocity is 0, after this time it returns back. So when it become return, its velocity is 0. So what is the time? So what is the clue here? At the returning the point, its velocity is 0. So here given E is equal to 5 minus 60. So F is equal to E cube. So charge is given 5 coulombs. Now F is equal to MA. So mass is given 0.1. So 0.1 bring towards this side, then it become denominator 5 by 0.1, that is 50. So acceleration is 50 into E. So E is 5 minus 60. I want to relation between the velocity and time. So A is dV by dt. So bring dt towards this side, then it become dt. So apply conditions. Now apply both side integration and also apply limits. So this is 0 to V and this is 0 to T. Integration dV, that is V. So upper limit is V, lower limit is 0. So final minus initial, that is V. 15 is a constant, so bring 50 before the integration, then 0 to T, 5 minus 60 into dt. See here, velocity is equal to 50. So separate the two terms, then we get 0 to T 5 dt minus 0 to T 60 dt. So integration 5 dt. So 5 is a constant. So integration dt. So that is T. So limits are applied 0 to T. So they will get 5T. V is equal to 50 into 5T minus. So what is integration 6T dt? So 6 is constant. Bring 6 before this. So this is 0 to T. Integration T, that is T square by 2. And 0 to T. So here 2 3s are. So this is 3T square. Apply limits T square from 0 to T, then we get T square. So this is 3T square. So this is 3T square. Look here. So this is the velocity and time the function. At what time the charge will return mean? At the returning position, its velocity is 0. At return time, its velocity is 0. So 0 is equal to 50 into 5t minus 3t square. So 0, bring 50 towards the side, 0 by 50, that is 0. See here, t is the common in both terms, then we get 5 minus 3t. So we get the answer t is equal to 0 or 5 minus 3t is equal to 0. So this is t is equal to 0 mean initial condition. So this is not a answer. 5 minus 3t is equal to 0 mean t is equal to 5 by 3 seconds. So this is answer. After time 5 by 3 seconds, the body return the back. Now the question, what is the velocity of a charge when E is equal to 0? So look here, at what time electric field is 0? Clearly given, E is equal to 5 minus 60. First I find at what time electric field become 0. Electric field is 0 at what time mean E is equal to 0, 5 minus 60 is equal to 0. So 60 is equal to 5, so T is equal to 5 by 6. See, at the exactly time 5 by 6 electric field is 0. So what is the question? What is the velocity? At the time t is equal to 5 by 6, what is the velocity? So already we solved velocity time equation. So substitute t is equal to 5 by 6 in this equation, then we get velocity. Now the velocity at the time is equal to 5 by 6. So 50 into 5 into time is 5 by 6 minus 3 into t square. So time is 5 by 6, t square means 5 by 6 whole square. So v is equal to 50, 5 into 5, 25 by 6 minus 5 square, 25, 25 3 is 75 by 6 6 is 36. So v is equal to 50. So LCM is 36. So 6 6 is 36, 25 into 6, that is 150 minus 75. 150 minus 75 means 75. 218 ja, 225 ja, 25 5 ja, 125, 25 7 ja, 175. So that is 188 by 18 meter per second. So this is the answer. Electric field become decreases, but it is the positive. So